Hello and welcome back. This video is very exciting, hopefully, because I'm going to show you a much more efficient method to compute the cross product of two vectors than splitting them up into ij's and k's like I did in the last video and working out using the algebraic properties of the cross product to get to an answer. Instead of this, I mentioned at the end of the last video, this can all be encoded, all of that algebra and all those cross products of unit coordinate vectors can be encoded into a certain determinant of a 3x3. So how this works is you take your u vector and your v vector and you lay them on row 2 and row 3 of a 3x3 matrix, and then you put the unit coordinate vectors I, j, and k in the first row like this. So you form this matrix, and then you compute the determinant of the matrix. And we'll use cofactor expansion, like I mentioned in the very first video of this section, to compute this. So what this looks like is u cross v is the determinant of this matrix, and then with cofactor expansion, it's this. All right, let's apply this. So we're going to do the same two vectors that I did in the last video, u cross v. We're going to check our answer a bit and also demonstrate this new method. So same two vectors, and I'm going to use the determinant of that 3x3. So first thing I do when I'm setting up this cross product is I'm going to write down that 3x3. So we have I, j, and k. And then I put my u vector, and remember the order, the first vector of the cross product has to go in the second row, 4, 3, -2, and then v is 2, -1, 1. I guess it doesn't have to, but this is, if you do this every time, you won't get it wrong. And then I'm going to compute the determinant of this matrix. So using cofactor expansion along the first row, that's going to be I times the determinant of this 2x2. Remember, cross out this row, look at the leftover 2x2, compute the determinant of that, and multiply it by this row 1, column 1. So that is I times, I'll write it like this, I times the determinant of 3, -2, -1, 1. Expand along the j, the j entry here, and remember that the second one, because it's row 1 column 2, that's 1 plus 2 is odd, this gets a negative, so this is minus j times the determinant of what's left over when I remove the first row and second column. So I get 4, -2, 2, 1. 4, -2, 2, 1. And then lastly, k, row 1, column 3, 1 plus 3 is 4, that's even, so this is positive, plus k times the determinant of what's left over, 4, 3, 2, -1. And then we just have to compute determinants of 2x2s. So this is going to be 3 times 1 minus -2 times -1. All right, so -2 times -1, that's a positive 2, so that's 3 minus positive 2, that's 1. So this is just I. J here, I have 4 times 1, that's 4, minus -4, so that's 8, and this is a negative, so that's minus 8j. And yes, there are a lot of signs you need to keep track of when doing this sort of calculation. That's maybe the hardest part, is to make sure you're keeping track of all the signs. So if you have to write all that down, go for it. Don't let me doing that in my head stop you from writing that whole thing down. 3 times -1 minus -2 times -1. Here we have the last one, determinant here. This is -4 minus 3 times 2, that's 6. So -4 minus 6, that's a -10k. Minus 10k. And if you do this enough, and you will do this enough because we have to compute a lot of cross products in this class, you're going to do this a lot. You're going to get real quick at it, maybe even faster than I am. And so we end up with 1, -8, -10 as the cross product of u cross v. So pretty awesome, slick formula that reduces finding cross products to finding determinants of 3x3 matrices. Pretty cool, pretty cool. All right. I hope you enjoyed that demonstration. I'll have a couple example videos after this of actually applying the cross product to finding some other geometric objects. And we'll use this method for actually computing the cross product when we figure out what two vectors we need to take the cross product of. All right. I'll see you there.